Okay, in this video I'll show you how to wind classic 3-inch coil for BBMPulser 3B, 5B, and they could be made out of 0.5 millimeter, 0.6, 0.8, and 1 millimeter. This one is specifically made from 0.8 millimeter strip wire. And in this video I will be using 0.6 millimeter strip wire to build another coil, and we'll show you the process start to finish, starting from raw material and finishing up a fully winded coil. This raw material you can get it from AliExpress. That's actually the only place I was able to find them. It's good quality product. It's 0.6 millimeter this section, and price for it is around $7, if I'm not mistaken, per meter. Yes, it's not cheap, but if you can find a cheaper place, let me know so I can buy some as well. For 0.6 millimeter, if I use 0.6 millimeter strip wire, for me to end up with 3-inch in diameter coil, I do need to use about 6.5 meters of this strip wire. This coil is 3 inches on edges and 1 inch inside diameter. It has a label for north side and insulating plate underneath, glued with silicone, heat resistant red silicone. Okay, let's get started. So the first thing I do is I cut section for 3 coils. For 0.6 millimeter it's gonna be 18.69 meters, so I'll go ahead and cut 19 meters section, probably 20 meters just to be sure. I have a meter right here. This is the length meter, and I made this hand, I don't know how you call it, roller. So I would put my coil into here, and then I would roll it through the meter onto here using the drill here, and get the section of 20 meters. It looks like this setup. I'm gonna have to do 2 coils, and here I have almost 13 meters, and that's enough for 2 coils. So the next step would be to clean this wire. So on one side in here the wire is sharp, on the other side it's fine, because there was a cutting wheels. They were pushing on one side, and on this side it left a sharp edge, and the sharp edge needs to be removed. Okay, for the next step I use this edge grinder, and on the sharp side here I would go like this, and I would remove the sharp edge. After the sharp edge removed, then I take this steel wool here, and I go again back and forth and squeezing it from up and bottom, and I will file it to make sure that both of the sides are smooth here on both edges and there is no sharp corners. Then I would roll it, and so on, move until I'm done with full spool. Okay, so the next step is to transfer from the large wheel onto the smaller spool, and as I transfer it I'm gonna wipe it with acetone to make sure there is no fats or any kind of grease on it. That way when I apply Kapton tape, it will stick to it very nicely. So for that I use a drill. I'm gonna need my other hand to hold this and spool it from one to another. So the next step is to wrap it. This is my wrapping machine. Here I have a spool with copper strip. Here I have a Kapton tape. This is a 30mm Kapton tape, and I'm gonna wrap it onto this spool here using a drill. So let's go ahead and do it. Here we go. That's how it looks after it's been wrapped up using wrapping machine. This type of quality you can only get if you use a wrapping machine. By hands, there is ways to do it, but not this good. You just can't get it this good. I tried a lot of different methods and you can't beat this one. So this in here is enough to yield for 2 coils. The next step would be winding the coil. The next step would be to install it into this spool dispenser, and once it's in here I can unwind it and wrap the coil. So let's move on to the next step. Next thing I use is this speaker supports. This is from the vehicle rear speakers. In one of them I cut the slot here. That's where the flat wire is gonna go, and it will start wrapping around. You'll need 2 of them and some bolts with nut. In addition, this is my wrapping machine. It's got PWM, pulse width modulator, which helps me to control the speed of it, and I use this 12-volt drill. It's connected to this 12-volt power supply, 6 amps. The amperage does make difference because you do need a crank sometimes. This is my foot pedal, and this is the variable resistor, which I can move up and down. Is behind this plate here. This is my dispenser for the coil, and I tighten it so that it's not moving easily. This way it's not unwrapping fast, and from there it's gonna go into here. Let me set it up. By the way, here is how I can turn it. I can increase the speed. Also, I can change the direction. And it's all done by pushing this foot pedal. Here is how this setup looks like. the next thing I would do is use 2-part epoxy. This is a 24-hour cure. Work time about 45-50 minutes. Sets in 5 hours type of epoxy, and I would use about 20 milliliters of it. I would put it in a syringe, mix it, put it in a syringe, and we'll start dispensing here as I roll it. As it rolls up, I have to use both of my hands, so I can't really show you, but you got an idea. I would put a little bit here like this along the way, and as I roll it, it will get squeezed out from the sides. Then I wipe it and keep rolling till I get full coil. Okay, almost done here. This is how it looks like, and there's some resin leaking. Sorry, epoxy. And almost done. Once I get to the end of it, I'll use caliper to make sure that it is exactly 3 inches, and then I use 15 millimeter Kapton tape to wrap around this coil around 5 full turns, and that will hold it in place. And there's a tricky part how to remove it, so I'll show you that. Okay, now it's cut, and I wrapped 5 layers of Kapton tape. This is also 15 millimeter Kapton tape. So the next step, I would carefully remove it from the coil, from the winding spool, and wipe it and set it. Yeah, let me show you. So next thing, I have to straighten it. So I have some board underneath, then I would lay the coil on it and use another piece here and just use a hammer and softly tap it all around to straighten it. After straightening it, here is how it looks. Actually, I gotta push this in a little more. Right here I can feel it, it's not all the way in. Gotta make sure it's completely straight. Then I would set it like this to cure and come back to it in 24 hours. After it's been drying for 24 hours, the next step, I would bake it for another 4 to 5 hours at temperature of around 220 Fahrenheit. And now it's done baking, so let's move on to the next step. So these are the insulating plate, and it goes underneath the coil. This is G10 FR4 material. It's 0.8 millimeter thick and 87.8 millimeter in diameter. So what I do, I take my sandpaper around 400 grit, and I would scratch one side everywhere. And then I will take acetone and I would clean my side, one of the sides of the coil, doesn't matter which side. And then I'll take this ultra red gasket maker high temperature silicone. I would apply on one of the sides that I scratched, and the side that I cleaned with acetone I would apply over, and I will push on the coil and squeeze out any excess silicone from underneath the coil. Then I would allow it to dry another 24 hours or so. Okay guys, so after coil dried out for the past 24 hours, I would remove all this red silicone from around the coil and inside the coil. I would use a knife, and this is what it looks like after it's been removed. After that, I would prepare center pin that would allow me to connect to the center of the coil. It's made out of same material, 0.6 millimeter strip wire that would go into here. There's a couple things I do. First, I would prepare spacer, and to cancel repelling force, this steel plate. Here is the magnet, so I can show you how they magnetize. So the spacer goes underneath here, and it's a little bit longer than the coil itself. Spacer is made out of G10 FR4 material. It's 1.6 millimeter thick. The reason why I add spacer here, because copper is going to be repelled by this coil, and if I place it directly onto here, first of all, it's isolation issue here. I have to have a spacer here because every time the pulse will be released, the coil will repel this strip, and every time it's gonna repel it, it's gonna try to move it, and eventually it's gonna destroy the coil and possibly shorten from one of these windings onto this strip. So that's what the spacer is being added here for. And in addition, to cancel repel force from this coil to the strip, I would add this steel plate. This steel plate is being added on the top here, and as the coil repels with each pulse, this copper strip, it will at the same time attract this steel plate. So this gets repelled, this gets attracted, and together they cancel repellent force for this strip. That's what I've been doing in the coils. It seems to be working well, and I recommend you to do it if you're going to end up building this coil. So these three pieces will need to be glued with epoxy. I would scratch the surface here, and I would clean everything with epoxy, with acetone, and would apply a little bit of epoxy underneath here and epoxy here. I would squeeze them together like this and put a slightly wise, something that would hold them together and allowed to dry out. So that's another procedure that will take another 8 to 12 hours for epoxy to dry, unless you have some fast quick dry epoxy. So I'll go ahead and do that. I'll prepare for both of these coils, and once it's dried, I will move on to the next step. Okay, now that I have these pieces dried up, I'm going to apply right here solder, right here, and then inside here. Then the next thing I'm gonna do is I will apply epoxy over here. Then I will place this over like this, and as I hold it tight, I'm gonna apply heat over there and solder it together. Let me do that and I'll show you when it's done. After applying epoxy underneath and soldering this center strip, wire into there. It's all soldered. I would clean inside with acetone, and I would apply a North Pole indicator. This is just a piece of paper that I print out, and I would apply epoxy down there and then stick it in there. So here is one already been done, and that would show a North Pole on the other side, just like that. Next I would mix some epoxy for these two coils, about 20 milliliters, and I would fill it up in the center hole like this, and so is the other one. And I will set it to the oven to cure, or I can just wait for it to dry out. And the next thing would be to attach in the thermal sensor. It's already started looking like this. All I have left is a thermal sensor. Thermal switch for these coils, I use 60 Celsius KDS 9700 thermal switch. That's what they look like. They come in this sleeve. I would remove the sleeve and use a piece of shrink wrap and apply it over, and it would look like that. These are 5 amp 250 volt thermal switches, 60 Celsius, and they can come either normally open or normally closed. For 5B, BBMPulser 5B, I'm using normally closed, and for BBMPulser 3B, I'm using normally open thermal switch. This is 0.8 millimeter. It will be used for 3B circuit, and this one gets normally open, but those coils that I'm curing right now, they are for 5B circuit, and they will be using normally closed thermal switch. So once I shrink wrap it, I would use Flexit 90. It's a two-part resin. You've seen it before. That's what I would apply over this coil to finish it up, and I would mix it and add it to the side here. This thermal switch should be not flat like this to the coil, but it should be slightly offset, just like that. That way it will trigger at proper temperature. Not too hot, not too cold. It will give you good enough session, depending on the circuit, around 10 minutes. Some circuit like 3B will give you about 12 to 14 minutes session time. Okay guys, I think that's about it. If you find something useful and like the video, please give me a thumbs up, subscribe, like it, share. For more, hit the bell for new videos, and I'll see you in the next one.